Hello everyone, this is complex variable tutorial 3, and in this tutorial we discuss about Cauchy-Riemann equation, CR equation in polar form. So we prove that del v by del r equals to 1 by r del v by del theta, and again we prove that del v by del theta is equals to minus r del v by del r. These are two proof. So starting from here, proof. So we know that from the polar coordinate x equal to r cos theta, and u is a function of x and y. Okay, u is a function of x and y equals to r sin theta. We know that. So z equals to x plus iy. So putting this value, r cos theta, I sin theta. So again we write that cos theta plus I sin theta equal to e to the power I theta in exponential form. So u plus iv is a function of xz, that is equals to function of r e to the power I theta, because this is equal to z. Okay, so now we consider this equation 1. So differentiating equation 1 partially with respect to r. So del u by del r, we take partial derivative. Okay, del v by del r equals to f dash of r e to the power I theta, and e to the power I theta is coming out from here. This is equation 2. Now differentiating with respect to theta, this is differentiating with respect to r, and now we differentiating with respect to theta, then we get del v by del theta plus I del v by del theta equals to f dash r e to the power I theta. Okay, to I theta, r coming out e to the power I theta into I. Yes, right. This is equation 3. Now substituting the value of this value, f dash of r to the power I theta, e to the power I theta, from 2 in equation 3, and we obtain. Okay, so this value is putting here in this 3. So this value is putting here. So we get the formula del v by del theta plus I del v by del theta in the left hand side, and in the right hand side we get, yes, right, what is the form? R del u by del r. Yes, right. Another term is r del v by del r, and into I. Okay, so now after some mathematical computations, we get del u by del theta plus I del v by del theta is equals to I r del u by del r minus r del v by del r. Okay, so now taking real and imaginary part, equating this real and imaginary part, we get del v by del theta equals to minus r del v by del r, and del u by del theta is equals to r del u by del r. So from here we say that del v by del r equal to minus 1 by r del v by del theta. So this is our one proof, del v by del r. So del v by del r, so del v by del theta. So now this is, look out here, del v by del theta and del v by del r. This okay. So this is the proof of this equation one is del u by del theta. This is the proof of this. This is, and del u by del r equals to 1 by r. Okay. So another equation is taking from these two part. So from these two part we see that del u by del r equals to yes 1 by r del v by del theta. So this is one equation we proved, and this is another equation, del u by del r, del v by del r. Okay, see here that. Okay, yes, right. So this is the first proof of representation of CR equation in a polar form. Okay, and now we discuss the topic derivative of W in a polar form. So now the next topic is derivative of W in polar form, in polar coordinate. Okay, we already know that W equals to U plus IV. We already know that. So now what is the value of del of W by del x? So there is du by dx plus I into del v by del x. Okay, so now if we compute d omega by dz, therefore we write this equation in the form del r by del x plus del omega del theta by del x. So now this is del omega by del r, because z is represented in r theta form, polar form. So what is the value of del r by del x? Del r by del x is basically cos theta, because r equal to cos r equal to x cos theta. So del r by del x equal to cos theta, and here we represent in this form this del omega by del theta is basically represented by this equation del u by del theta plus I del v by del theta, and this is del theta by del x equal to basically sin theta by r. Okay, and these r comes out from this del omega by del theta term. So now we see that after some mathematical computation, and if we put this value here, del u by del theta equal to minus r del v by del r, and del v by del theta is equals to r del u by del r. Okay, then we get in this form cos theta minus I sin theta is equals to into del omega by del r. This is equation 1. And the second form of d omega by dz, in the second form of d omega by dz in the terms of theta, d omega by dz. So now we expressed again in this form del omega by del r, then del r by del x, del omega by del theta by del x. So now this is omega u plus iv, okay, by del r into cos theta. Yeah, right, this is d omega by d theta, this is sin theta by r. Okay, so now if here we put after some mathematical computation, and if we put this value minus r del v by del r and del v by del theta is equals to r del u by del r, if we put this value, and after some mathematical computation we get minus I by r. Students, please do these mathematical computation steps in your own way. Okay, don't follow the books, please do it in your own ways. Okay, and one thing should we remember here also, we know that minus I by r del omega by del theta is equals to del omega by del r. This condition also necessary for the mathematical process. So now these are the two derivative, one d omega by dz in the term of del omega by dr. This is one equation, and another equation is that del omega by del z in terms of theta. So this is the derivative form of w in a complex variable. Okay.